All right, so get this. Scientists think they may have found a planet that looks, well, a whole lot like Earth. It's rocky, it orbits a star like our sun, and its year feels incredibly familiar. But, and this is a big but, there's a huge twist, a big icy catch that could change absolutely everything.
So that's really the ultimate question we're digging into here, isn't it? Have we finally done it? Have we found Earth 2.0? Well, the answer, it's a lot more complicated and frankly a lot more interesting than a simple yes or no.
So let's meet our main character. The world at the center of all this excitement is called HD 1370-1010b. Yeah, I know, it doesn't exactly roll off the tongue, but it's a name you might want to remember. It's about 150 light years away from us, which, in the grand scheme of the universe, is practically in our cosmic backyard. Okay, so to really get why there's so much buzz, we have to look at the clues. There's a whole checklist of reasons that this thing has astronomers paying very, very close attention. I mean, this planet checks an unbelievable number of boxes. For starters, it seems to be rocky, not a big ball of gas, so you could theoretically stand on it. It circles a star that's really similar to our own sun, and here's the kicker. Its year's estimated to be about 365 days, just like ours. That is wild. It is a little bit bigger than Earth, and crucially, we can actually watch it pass in front of its star, which is called a transit. All of this places it right there on the outer edge of what scientists call the Goldilocks zone. You've probably heard of it. It's that sweet spot, not too hot, not too cold, but just right for liquid water to exist on the surface. And as we all know, liquid water is kind of the magic ingredient for life as we know it. But how in the world do we study this thing from so far away? It all comes back to that transit I just mentioned. When the planet crosses in front of its star from our point of view, it causes this tiny, temporary dip in the star's light. The analogy is perfect. It's like watching a tiny bug crawl across a flashlight beam from miles and miles away, and that little flicker lets us measure its size and orbit with incredible precision. Okay, so it all sounds amazing, right? A rocky world with a 365-day year? But hold on, because this is where the story takes a very sharp turn. This is the big icy catch. That potential paradise? It might actually be more of a frozen wasteland. Just take a look at these temperatures. For a little context, Earth's average is a pretty comfortable 59 degrees Fahrenheit. Mars, as you can see, is a frigid -85. But our potential Earth twin, HD 137110b, it could have an average surface temp of around -90 degrees Fahrenheit. That's not just grab a jacket cold. It could be even colder than the red planet. So yeah, -90 degrees, that is bone-chilling. But why? Why is it so cold if it orbits a sun-like star? Well, its star is more like our sun's dimmer cousin. Think of it as the same type of star, just with a lower wattage bulb screwed in. This means our candidate planet gets less than a third of the heat and light that we get here on Earth. And if the freezing temperature wasn't a big enough hurdle, here's the other plot twist. HD 137010b isn't technically a confirmed planet. Not yet. Right now, it's what scientists call a candidate. The whole scientific process just needs a little more proof. So this is basically how it works. To officially confirm a planet is really there, you have to see that dip in starlight happen more than once and on a predictable schedule. We've seen one transit, which is fantastic news. But because its year is so long, we haven't seen the second one yet. We're literally still waiting for it to come back around. Now, while we're waiting for that confirmation, it's really important to remember that this planet isn't alone. It's part of this growing family of totally fascinating worlds that are bigger than Earth but smaller than giants like Neptune.
We call these planets super-Earths, and it turns out they're a pretty common type of planet in our galaxy, and they come in all sorts of weird and wonderful varieties.
Just look at this lineup. You've got Gliese 667c, which might get blasted by dangerous solar flares. There's Kepler 22b, which has an orbit like Earth's, but we have no clue if it's rocky or made of gas. And then you have TOI 733b, which some scientists think could be a world completely covered in one massive ocean. Each one is a totally unique puzzle. So let's bring it all back to our candidate, HD 1370-101b. Given everything we know, the good and the bad, what are its actual chances of being habitable? Well, the truth is, it's basically a cosmic coin toss. When you run all the computer models, you can really see the uncertainty. If you combine the conservative and optimistic chances, you get just over a 50% probability that it's in some kind of habitable zone.
But that also means there's almost a 50-50 chance that it's outside the zone altogether. It really could go either way.
But there is one wild card that could change everything: a thick atmosphere. See, if this planet has a dense blanket of gases around it, it could act like a planet-sized winter coat. It would trap heat from its star, and that could potentially raise the surface temperature enough to melt all that ice and allow for liquid water. And that right there leaves us with the ultimate question. Is HD 137010b a frozen, barren ice cube, even colder than Mars? Or is it a hidden oasis, a water world tucked away under a thick, protective atmosphere? For now, we just don't know. And that uncertainty, well, that's exactly what makes this whole search so unbelievably exciting.